Hello and welcome, everyone. It's a pleasure to introduce Professor Dr. Volker Auwärter from the University of Freiburg for the lecture today. He's one of the leading toxicologists in the field of new psychoactive substances in the German-speaking world. He was the first to discover and identify the synthetic active ingredients in the herbal incense spice after trying it himself. He also conducted a self-administration study with 1P-LSD, and that's what he will be talking about today.
Thank you very much. So as Jonas already said, I'm in forensic toxicology, which is not so much about psychedelic research, but more about crimes and drugs in relation to crime. But of course, not only the detection of drugs is important in this context, but also how do these drugs act, what are the consequences, for example, in relation to a crime that was committed and so on. So that's why we also do some psychedelic research in forensic toxicology. Okay, and today it's about 1P-LSD, which was the first, or one of the first acyl derivatives of LSD. They came onto the market about 2015. And as you see in the upper picture, the difference to LSD is just that a propionyl group was added to the nitrogen at the bottom ring. And one derivative that is very similar has been on the market before. It's the ALD52. You see there is an acetyl rest on the nitrogen, which looks very similar to 1P-LSD. And here you see a few other derivatives that were on the market already for a couple of years before. So why do we see these analogs of LSD? Of course, it's because LSD is a prohibited substance in most of the countries worldwide. And so there is always an urge to find new substances that are not regulated by the Narcotics Act. And that's why this motor is keeping running. 1P-LSD, as I said, was one of the first that really emerged on a broader scale on the European market for LSD derivatives. And that's why we started to investigate this drug a couple of years ago. That time, 1P-LSD was still legal in Germany. It is not anymore because now the new Psychoactive Substance Act came into force in Germany. It was end of 2016 already. And after a few years, a group of substances related to LSD was also added to the annex of this law. So nowadays, 1P-LSD is not legal in Germany anymore, but a couple of other substances still are. So as you see here again, it's LSD and 1P-LSD. And then we saw a couple of other analogs with prolongation of the aliphatic rest that was attached to the nitrogen. So a butyl homolog, a valeroyl homolog, and finally the last one that appeared on the market, I think it's 2 years ago, around about, was 1D-LSD with this structure here. You see there is a 4-ring added to this molecule, and this is still sold legally in Germany. It will be illegalized very soon by a new definition of the annex of these LSD analogs in the German law. But up to now, it's still legal. And the interesting thing is that although one by one was scheduled under the annex of the NPSG, since approximately 5 or 6 years, we have a steadily available class of drugs that is analogs of LSD, which everybody can sell in quantities as he likes. Also in different dosages, so you find microdoses, you find mini doses, or really high doses also in blotters or in this form of paper trips. So actually 1D-LSD is a drug that never really appeared on the market because what was really sold was this molecule. It's 1T-LSD, and you see a thiophene ring here. That is the real structure. This was just a trick. They bought it as 1D-LSD with this structure, but actually it turned out to be 1T-LSD. And why did they do it? It was just a trick because they have the same molecular mass. So with if you don't use a high-resolution mass spectrometer, you can't differentiate these two compounds. So the idea was, by law, 1D-LSD will be forbidden, and then the manufacturer can come and say, this was the wrong one. We did not really sell 1D-LSD, it was 1T-LSD. So probably that was the intention of marketing it as 1D-LSD. Anyway, this is still legal, but also the thiophene ring derivative will be legalized within a few months. And then we have to wait if the chemists will find another way to circumvent these legal restrictions. Anyway, what I wanted to say is since more than 5 years, we have a legal availability of active LSD derivatives in Germany, and astonishingly, not much happened. So we don't have, mass poisonings or people freaking out and running naked over the streets or something like that. Nothing really happened. So that's quite an argument for having a liberalization of this kind of drugs, because they don't seem to be really dangerous. If they were, we would have seen a lot of intoxications and problematic cases, but we did not. They kept on the same range as they were before, when no legal LSD analogs were available. Okay, what was already known before we did our study was that 1P-LSD is used in doses similar to the doses that are used for LSD, so between 50 and 150 micrograms. Onset is similar, and the duration of effects is also similar like LSD, and also, if you look at the effects, they very much look like the effects we know from LSD. So the question was, what is really happening with this drug? Because it was not quite clear. There were also some receptor studies, and 1P-LSD also binds to the same receptor as LSD, but it was not clear if 1P-LSD itself is the active compound or if it is just a prodrug, because this amide binding can be cleaved very easily by enzymes, for example. But first we had to look at the stability of 1P-LSD. That's important for the analytical method, because if we want to do a pharmacokinetic study, we need to know how stable is the analyte in blood or in urine matrix, for example. And well, the second question was to investigate if these acyl derivatives are prodrugs of LSD or if they are acting by themselves. So, sorry, that was one too quick. So for stability, we did just a standard setup. We spiked urine and serum samples with the compound. We pooled and aliquoted these samples, and then we stored them under different conditions, different temperatures, with light or in darkness. We used brown tubes or white tubes. And we also tried if addition of sodium fluoride has a stabilizing effect. And we stored, of course, for different time. And finally, we analyzed all these samples to get an impression of the stability of the analyte in these two matrices. This is something about the sample preparation and how we measured it. It was with liquid chromatography and tandem mass spectrometry, but I won't go into details because that's rather technical. More interesting is the result of these experiments, because what we found was that the analyte is quite stable in urine and in serum matrix, not depending on temperature and light or darkness. You see, under light conditions, it's stable even under room temperature, which was not expected. We thought that under room temperature, the concentrations will quickly decrease, but they didn't. And only here in this last sample under room temperature, we had a decrease of the signal. So, of course, after a few days at room temperature, there can be some instability of the analyte, but it's not so strong as we thought it would be. So from an analytical point of view, there's not a big problem about that. Here's also, here this was 1P-LSD, and we measured 1P-LSD, and then we measured also LSD, which is the degradation product of 1P-LSD. And we see a slight increase of LSD concentrations in these samples. That means there is a little hydrolysis of this amide bound in these samples when they are stored, but it seems to be so small that it's negligible with regard to the concentrations we spiked to the sample, although it's measurable in very, very low concentrations. And what was also interesting is that light was not an important factor, because that is from an older publication that we know that LSD seems to be unstable under light, especially under UV light, which gives energy that can be absorbed by the molecule and which leads to instability. But we couldn't see that for, at least for 1P-LSD, under the conditions we chose. So that was somehow impressive. We also see that under the darkest conditions in the sample, where we had a decrease of the concentration, we have even a decrease of LSD. So it's not degraded to LSD. There must have been some other degradation, oxidation, for example. So stability was not really a big problem, and you have to see here that is the signals, and they are different in serum and urine. So what we see here is enzymatic cleavage, because under room temperature in serum we will still have active enzymes, and they obviously can degrade 1P-LSD to LSD. Although not to a really big extent, but at least even here okay, it's of course different from a living organism, but still in a drawn serum sample we have some degradation, and that should be enzymatic. Okay, interesting what was that degradation is not triggered by light, which we really assumed because of the known problems with LSD in biological samples. It is temperature dependent. That was also expected. So freezing is a good idea, of course. And sodium fluoride stabilizes, at least in serum, the 1P-LSD, because sodium fluoride inhibits many enzymes. And of course, that's why we, for our study, we chose opaque glasses. We don't need brown glass. We stored the samples at -20 degrees prior to analysis, and we added sodium fluoride just to be sure there's no enzymatic activity anymore in the samples. And under these conditions, it's no problem to store the samples for some time. Okay, now the experiment we did, it was 2 male persons. One was me, one was a good friend of mine. And we really wanted to know about the oral availability of 1P-LSD, because in the literature we didn't find any data on LSD oral availability. And I don't know if you are aware of any study where this was published, but we didn't find it even in the old literature, which is quite I was wondering about that, because LSD is a very well investigated drug, but this data is missing in the literature. So anyway, we wanted to know that, and that's why we chose a setup where we first applied intravenous dose and then the same dose by oral administration, because only by that way you can find out about the oral availability of the drug. The difference is usually due to first-pass metabolism. And for many drugs, this first-pass metabolism is very high. That means 80% or more of the drug don't reach the circulation. And of course, that's also important for LSD because LSD is usually administered orally and not intravenously. There are some studies where LSD was applied intravenously, but they are scarce. Okay, so two conditions, one intravenous dose and the same dose then in a second experiment as an oral dose. And we collected serum and urine specimen because that's the normal specimen we use in forensic toxicology. Sample preparation, again, is not so interesting, and we again measured with LC-MS. Here's some details on the method. The most important thing is that we validated the method for very low concentrations because we wanted to be able to find even very small amounts of 1P-LSD and LSD, of course. And as you see, the limits of detection are in the range of a few picogram per milligram, which is the thousandth part of a nanogram per milliliter. So that's a very small concentration we were able to detect here. And of course, we've validated the method, but I don't want to go into details here. I could just state that the method worked fine. So we could start the study. Okay, matrix effects is always something you have to look at if you do LC-MS, and of course we checked that for the method as well. And here are the first results for the first condition where we applied 100 microgram of 1P-LSD by the intravenous route. And this was quite interesting because what we saw is that 1P-LSD itself is only measurable for a very small interval of time. So after 2 or maximum 4 hours, there was no 1P-LSD in the serum detectable anymore. And on the right graph, you see that from the first sample taken a few minutes after the intravenous application, we already saw LSD in much higher concentrations than 1P-LSD. And that proves already that 1P-LSD is very quickly transferred into LSD, even after intravenous application. We will see what happened with the oral route, but that was a bit of a surprise, maybe. Also, the Cmax, you see, it's less than 1 nanogram per milliliter, whereas the maximum for LSD was 2.5 or even a bit more nanogram per milliliter. And even more than 24 hours, we still had detectable amounts of LSD in the serum samples here. So, if we look at the oral ingestion, even in the first sample, we did not detect any 1P-LSD. And that means that from the oral route, 1P-LSD is completely hydrolyzed to LSD before it enters the circulation. So it's a classical prodrug. You don't even find the product itself, even at very low picogram per milliliter concentrations in any of the blood samples. That again was not expected. The Cmax concentrations were similar as they were after the intravenous application. And one detail that was also surprising, at least for me, because I didn't know that from studies, when we applied the LSD intravenously, we expected the effects to start at a very early time point. But actually they didn't. It took about the same time as after oral ingestion, about half an hour or a bit more. until we experienced the first effects. And that was a surprise, because after intravenous administration, you would expect the first effects after minutes. That was not the case, and that, well, led us to the hypothesis that the blood-brain barrier is the thing that has to be overcome by the LSD, and it's not about the absorption from the gastrointestinal tract. So that again was kind of a surprise. I didn't expect that really. And secondly, although we can't, of course, really measure the strength of the effect, but the effects were more or less the same from the intensity after oral or after intravenous administration. There was not a big difference between these two modes. Okay. In urine, of course, we also looked for LSD and 1P-LSD, and we didn't find any 1P-LSD. That's not a surprise in all the conditions, but only LSD and a few metabolites of LSD that are known, like 2-oxo-3-hydroxy-LSD, for example. And we were able to find LSD in urine until more or less 90 hours after the application. So still after a few days of ingestion of 100 microgram of this drug, we would be able to detect it in a urine sample, for example. Of course, that's interesting for the forensic context, and not so much for the pharmacokinetic. Okay, and that's it already. So what we found is that 1P-LSD is a prodrug, and we would assume that all of the other acyl derivatives like ALD52, Valeroyl LSD, or 1D or 1T-LSD will also be prodrugs, because it's always the amide bond that has to be cleaved, and very likely the same enzymes which are capable of cutting the 1P part of the molecule, they will be able to cut the other parts as well. Okay, then after oral ingestion, this is a very quick process, so it could already happen in the gastrointestinal tract, or it should happen there, or it's very quick as soon as it reaches the blood circulation that this hydrolysis takes place. So we didn't investigate that further, but anyway, it was a very quick process. It is a classical prodrug, as I said, and we had a very high oral bioavailability of 1P-LSD if we refer the AUC, the area under the curve, to LSD, because that was the measurable drug for both conditions. So, and it was close to 100%. That means the first pass effect is more or less non-existent for 1P-LSD, and we would guess that it is the same for LSD, which I said at the beginning. In the literature, there are no data on this question, but I would guess that LSD also has a close to 100% bioavailability, and that could be, of course, a reason why the oral route is working well. It's not like for drugs which have a high first pass effect, you can have a high variability of effects with the same dose, because it depends, on the height of the first pass effect. So if you don't have the first pass effect, one dose will have similar effects each time. So it makes sense for LSD to have something like a standard dose, which mostly works. The delay of onset of effects was similar after oral and intravenous administration, and that makes it likely that the blood-brain barrier is the important thing here, and not so much the absorption from the gastrointestinal tract. And finally, although it is not verified so far, we can at least hypothesized that pharmacokinetics for other acyl derivatives will be very similar to the data we gained for 1P-LSD. If you want to read more about the details of the studies, that is published also in the journal Drug Testing and Analysis, where you can find also some psychometric data we gained. I didn't focus on that today because it was more about the role as a prodrug here. But I can tell you it really works like LSD. There is no difference if you look at intensity and the kind of effects we experienced. And that's in line also with all the reports in internet fora, for example, where people tried out these substances, the different acyl derivatives, and it was always more or less the same. Of course, dose has to be adjusted somehow because the molecular weight is higher, of course, than that of LSD. So in tendency, you have to use a bit higher of a dose than for LSD, but it doesn't make really such a big difference. It's in the range of 10 to 30%. And that's it so far. Thank you for listening. And I'm glad to answer questions if you have any. Thank you.
Okay, thank you so much for this introduction into the effects of 1P-LSD. We'll now be taking your questions. Just raise your hand and we'll come to you with a microphone.
Hi, thanks very much for the talk. I'm wondering, would you care to speculate on why there's not more market 1P-LSD, given the, let's say, the advantage of the resistance to ultraviolet light degradation? It strikes me that this would somehow become a more viable street drug in that respect, and we don't see that so much. So, yeah, do you speculate on, for example, difficulty of manufacture or some other reason?
Actually, I'm not so sure if we don't see that, because from a forensic point of view, we can't differentiate if somebody took LSD or 1P-LSD, because what we see in serum and urine afterwards, it looks just the same. Because after the oral route, we didn't find any 1P-LSD in any of the samples. So from my perspective, I would say, although we monitor these acyl compounds in our screening procedures, we would not see a difference if somebody takes 1V-LSD, 1D-LSD, 1T-LSD, 1P-LSD, or 1CP-LSD. It doesn't make any difference. So what I would suggest is that quite a part of the positive cases we have, which is of course only a small proportion of, I mean, it's not very often that people come into conditions where police takes a blood sample, you know, for after having taken LSD or LSD analog. But in these cases which we have, traffic cases, for example, where people drive under the influence, or other instances where something, you know, accidents happen and so on. I would guess that quite a proportion of these cases is due to 1P-LSD and other derivatives, and not so much about LSD. Because these online shops, they, of course, they offer these drugs in big quantities, and they also sell it in big quantities. So it's not just, you know, something that could be used, it is really used. And it's much easier to access than illegal LSD trips, which have always been a bit difficult to take grasp on, because it's only local, there's only a local distributor maybe, and only for some limited time. But it's not so common like cannabis or amphetamine, for example. So I guess quite a proportion was really using these derivatives instead of classical LSD.
Thank you.
I actually have two questions. The first one would be, you said you can kind of expect the same thing for other derivatives. Can you give us some intuition what it depends on, if it can be split off or not, like on the molecular structure?
Mm-hmm. Well, there is the possibility that if you have really bulky rests that are bound to the nitrogen, then the enzymes will have difficulty, to access. I don't know where the limit really is, but it's well known for the valeroyl, which is a longer chain, that it still works. And also for the 1P-LSD, the thiophane ring, which is not really bulky, of course, it also works. So I guess all the derivatives we have seen on the market so far, I'm quite sure that they pretty much work the same as 1P-LSD does, or ALD52, which is even shorter from chain length. But that still has to be investigated. So right now I'm not planning a second study of this type. Actually, it was a bit of an adventure to administer LSD intravenously. I was not really scared, but I thought, okay, could be a surprise. I was a bit nervous in the beginning. I thought, oops, what will happen? But it was really smooth. There was no difference. It took really more than a half hour to have some first slight little effects. And well, I really believe that for all these drugs we have seen on the market so far, it works pretty much the same. If you have a really big, bulky rest, then you will come into trouble. But so far, I think they all work the same.
And if it was not possible, there would be no effects, probably.
Sorry?
If it was not possible to split it up, then you would expect that there's no effects of LSD?
No effects or little effects. Because if you have such a bulky molecule, it will most probably not fit to the receptor anymore, which is a specific subreceptor of the serotonin receptors. And I would think that they don't work. I mean, for 1P-LSD, it still works even as a whole molecule without splitting off the rest. That was already done, although it's meaningless because it's not circulating. So if it binds or not, it doesn't really matter. But for the bigger molecules, I would presume that they, from a certain bulkiness of the substituent, they will not work anymore.
Okay, can I have another one? So the other one was a bit more recreational. You said it lasts for 36 hours in the urine. So
90 hours even, yeah.
90 hours.
Mm-hmm.
So do you know how it works with the tests when you're driving? So if I would do LSD, I couldn't be driving for 4 days? Or
I don't know about Switzerland, but in Germany there are no road on-site tests for LSD. They have cannabis, cocaine, opiates, amphetamines. That's it. Maybe methadone and tricyclic antidepressants or something like that. But LSD test is not usually made on the streets. And if it is made, I don't really know how sensitive it is. I would guess that it's not very sensitive because with an antibody quick test, and these are all antibody tests, it will be difficult to reach such low concentrations. Not impossible, but it's a rare occasion that someone drives under the influence of LSD. It's not a good idea, by the way. But of course, I know what you're talking about. Now it's 3 days back, and you feel very fine, and you sit in the car, and then the question is, can I run into trouble because there is some rest in the urine? But I would say our method was capable to detect really very, very low amounts of LSD and metabolites in urine, and an immunoassay would not be by any means. I think even if you have a very good test, it will not be more than 24 hours.
Okay, thank you.
just wanted to add something to that. If you would be tested for LSD, with such a test, wouldn't it be impossible to tell whether you took a legal, like 1P-LSD or something? I don't remember the currently legal ones, but one of the legal compounds, because they all break down to LSD.
Completely true. That would not be possible to distinguish. But anyway, if you drive under the influence, it doesn't matter if the drug is legal or illegal, because the main thing is that you drive under the influence and you are not capable of driving safely. And that's why you get punished, at least in Germany. I think it's very much the same in Switzerland. So even if you take a legal drug, a medication, for example, and you are not able to drive because of the effects of this drug, this is a legal offense, and then you will be punished for that.
And if you don't drive?
If you don't drive, no problem.
Thank you.
Yeah, actually, that's a difference maybe in the legal systems. In Germany, it's not illegal to consume a drug. It's illegal to possess it, to buy it, to give it to somebody else. All these things are not allowed, but to use a drug is not punished.
Okay.
But I think that could be different in Switzerland. I'm not so sure. It seems a bit paradoxic, but the thought behind it is that if you use a drug, the only one you might do harm is yourself, and even suicide is not punishable in Germany. So,
thank you.
Just curious, on the slightly more personal side of your experience, how did it feel taking serum samples every couple of hours while quite high?
Yes, I would say it didn't help the experience because it's a bit stressful. Like you have this catheter here, and then I'm quite used to that because I did a lot of self experiments, also with completely other topics. So it's a bit stressful, and you don't get the full potential of the experience by that. I'm quite sure about that. But you know, what don't we do for science?
I might be able to add on that. At the Psychiatric University Hospital, we also take blood serums from the patients while they're under the influence of ayahuasca analogs or something like that. The experience tends to be slightly distracting for the people, but by no means like uncomfortable. Like one could expect that if you have a needle in and constantly see blood, that it might influence the trip in a bad way. But the participants we have had so far have not experienced that, so it seems to be well tolerated.
I mean, it was a bit more difficult for me, at least, to fill in, you know, these forms about where the questions about the effects are given. So we laughed a lot about that because then there was a question: do you have a mystic experience? No, very much, extremely. And then we were just arguing, what do they want from us? I don't know. And we were quite laughing a lot. And this was even more distracting, I would say, because there were students who took the blood samples, and you could just, you know, put your arm like that, and they just did it. Although we did it with each other also then later on, because we took samples for more than 24 hours. But anyway, it was distracting sometimes, and I would not recommend it as a standard operation.
So thank you very much for your talk and sharing your experience. I was wondering, can you tell us a bit more about the setting of the study? Because I'm feeling that you're following Shulgin's path in a way, because you're self-testing things, because there is a gap in the scientific knowledge. So are you at the end of the day suggesting that we should be doing this kind of self-testing experiments? Because there's a gap.
Mm-hmm. Well, I find it very helpful to have these experiences, because if I testify in court, for example, and I don't have a subjective experience of the drugs and how they could act, then it would be very difficult. I mean, of course, you can read a lot and you can extrapolate things, but it's really different to have a subjective experience. Although that doesn't cover everything, of course, that's clear, but at least you have a glimpse of where it could lead. So I think it's very valuable even in the forensic context. And well, of course, it's interesting anyway. So the forensic view is only one particular part of the whole picture, which is more in focus, of course, for our profession. But anyway, these substances are very interesting. I also did a self-experiment once with a designer benzodiazepine, and I would never repeat it. So because I have there's a big hole. I don't know anything of this of the complete afternoon. I did not do strange things, thanks to God, but anyway, it was a very strange experience, and didn't feel like doing it again. Actually, it was by mistake. I took 0.5 milligram of one of these substances, but it was a very, very potent one, and 0.5 milligram was much too much, but I didn't knew that beforehand. So that was kind of an accident, I would say.
Well, it sounds a bit like Bicycle Day in a way, with Albert Hofmann, literally.
Yes, actually, I wanted to drive home with my bicycle, and my colleagues held me back because that would have been a catastrophe, because I was really not able to drive a bicycle anymore. I could hardly walk.
I'm sorry if I can proceed with my question. How easy it was to organize this study and this self-administered study?
Okay, that was quite easy because, as Jonas said, I did it from the start. It was in 2006 when I did this first self-experiment with this spice drug that was sold that time. And actually that was a breakthrough for our research also, because then we started to really search for the active substance, and then a few weeks later we had it. But it is quite easy because, at least in Germany, we don't have legal restrictions on self-experiments. I can do it whenever I want. Of course, it's my own fault if something goes wrong. Nobody will be capable of that, but it is easy. So usually I did it at home or at the institute, in a safe place. Of course, also with medical care if something happens, and it was really no problem, I would say. It's not the effort you have to take when you do a clinical study with 5 or 10 persons with an ethical, application and so on and so on. That has become really difficult to do proven studies, and for us it's very feasible to do self-experiments from time to time because the data we gain is very valuable. I mean, if you have 2 or 10, of course it makes a difference, but to see in principle what happens, it's more than enough if you have n equal 2. But I know in some other countries that is not so easy. For example, in the US, the colleagues always say, we couldn't ever do something like that. We would be sued, and get really into big trouble if we do that. But maybe that's because also of this legal position that administration even of illegal drug is not a crime. So how can it be a crime to do research in this area? Yeah.
So, thank you very much for the talk. You've also quickly mentioned a lot as a derivative, but I also heard that a lot has different effects. So how do you compare it to 1P or all the other acyl derivatives you've talked about?
Yes, LAD, you mean the one I showed in the beginning?
Yes, yes.
Go back, because that's really different. Here it was, the LAD, because here you have another substituent at the second or the other nitrogen here, and that is not cleaved so easy because it's not an amide bond, but that will not be cleaved easily. So that's really a compound that acts by itself, and that would be natural that it has slightly different effects from LSD. I'm not aware how exactly different, but it would be very likely that the effects are different. Maybe from quality and quantity. Also, the dose might be different. But I'm not really. I don't really know about LAD, and I'm not aware also of a lot of publications on this compound.
No, thank you.
Yeah, just two questions. I don't have a background in chemistry. So the first one is, if you add something to LSD, to this molecule, like, couldn't this also have like negative effects? And what would those be? And then from a legal standpoint, like, why is it so, or like, why can such a substance be legal? Like, for me, it would make more sense to ban the substance itself, and then whatever you add to it would still be illegal?
Yeah. Maybe for the first question, potentially these compounds could have some toxic effects. But as we know that they are cleaved quickly into LSD and then an acid, basically, the question is if these acids are toxic. So for acetic acid, which would be the equivalent to ALD 52, we know it's not toxic. For 1P-LSD, it will be propionic acid. It's also not toxic, at least not in these very, very small quantities. We have to remind that we talk about doses of 100 microgram of the active compound. That means only a small proportion of these 100 microgram will come into the circulation as the corresponding acid. So it's really tiny amounts, and it's very unlikely that these will have any toxic effects on the body, unless you really have some, I don't know, halogenated compounds which might be very acidic, for example. It's not very likely. Even the thiophene ring, which doesn't look very nice, I admit, from a toxicological point of view. I'm sure that is a toxic compound if you ingest it in a bigger amount, but not in these really tiny quantities. So I wouldn't expect any negative effects from these additions at this nitrogen. So if you change the molecule in other ways, at the ring systems or even at the amine function on the upper part of the molecule, then you could have really new entities with completely different toxicological properties. So that's unknown. But at least for these acyl derivatives, I would say they are safe. You couldn't expect really toxic effects from these drugs. As we know, LSD is really one of the most potent drugs we know in pharmacology. It's active in 50, 100 micrograms, really very low doses, even for the most toxic compounds we find in natures are usually toxic in higher doses. So yes, these acids which are built from the cleavage of the rest will be in the system only in very small amounts anyway. So that's not a big problem. And to your second question, it's really a problem for the legislator to keep pace with these developments in the new psychoactive substance world, because in most laws which deal with narcotics, you have single substances which are defined in an annex of the law, for example. So everything that is is prohibited, and anything that is not mentioned in the text of the law is not prohibited by definition. So you have to add each and every new compound that appears on the market, and that is a cat and mouse game which the legislator cannot win, because there are so huge possibilities in manipulations of the structures that it's more or less endless. You can't really keep pace with that. So what many legislators, also the German, did with the NPSG is that they defined groups of substances on the basis of their chemical structure, and then they leave it open. For example, a substituent can be this, that, or that, a composition by atoms or defined other structural elements, and and these are all prohibited then by one in a group of substance. So, but that's a bit tricky, because on the one hand you can cover a lot of things that could appear on the market just in advance, but on the other hand you prohibit a lot of substances which are merely not active, because all the different substituents you can put together, many of these compounds will not even be active. So you prohibit a lot of substances which are not even active. And that's, of course, that's a conflict of interest, I would say, because law should never forbid things which are, not dangerous or not harmful. But by these definitions, you do. There's no other opportunity. So that's already a compromise. And even this compromise is not working well, because what we see since end of 2016, where we have, for example, this definition for synthetic cannabinoids. And chemists always managed to circumvent the newest version of the law by inventing some new structures, by going through the patent literature and the scientific literature, and you always find a structure that is still a little bit different, not covered by the definition, but active at the respective receptor. And since 2016, they did not manage to make it waterproof in a way. So we always see new compounds appearing on the market. But if they appear, then the definition is broadened, and then the whole group of substances is also prohibited. And then you need to be more creative and find something new again. And this becomes more and more difficult, of course, but it doesn't seem like we have reached an end in this development, because as you might know, we still have about 50 new compounds every year that appear on the European drug market, and this is very stable now since 4 or 5 years. It used to be 100 and even more than 100 a year. And before 2006, it were maybe 5 to 10, and most of them were from the famous books of Alexander Shulgin. And this really exploded after 2006, 2007. And well, now we still see 50 new compounds. It's 1 compound a week, more or less, that appears newly on the market, which has never seen before. And this is, although we have some laws in place already in all European countries, they managed to, I think Switzerland, you also have an own annex where the new psychoactive substances are listed, and all the other countries also did, but that didn't stop this whole development. So there seems to be quite an urge to have legal drugs on the market.
We're running out of time, so we're going to take 2 more questions that I see. Otherwise, I think Dr. Auwärter might be around after the talk for a couple of minutes, and maybe we can pass on his email if there's some questions. But just to keep it in time, we're going to take 2 more questions. I think you had one over there. Okay.
Thank you. I guess the same mechanisms will be true for microdosing, for small dosages. What you mentioned, the bulky, bigger substituents would have a slower metabolism to the active substance, and possibly the prodrug effect would take longer with the bulky substance, so that you would be able to produce a longer lasting effective dose of the active substance if you were able to find substituents that are much slower in metabolism. This way, I would assume that you could produce much longer lasting levels of the active substance. Would you agree?
That's at least possible. You would need higher doses then, because you release only small amounts per time, and you would need higher doses, but it could be something like a reservoir, and then you could have longer lasting effects. That's at least plausible. And in pharmacology, it's something that is often used if you have these formulations which release the active substance more slowly. Of course, you can also reach that by formulation, by integrating it into a matrix that is releasing the active component more slowly. But also, prodrugs are or have been invented with this advantage of slowly releasing the active compound and then prolong the effects, or speaking from a medical point, to reduce the frequency of dosing that is needed, which would, of course, not be a point with LSD, because nobody would really want to prolong this even further. 10 hours is already something, you know.
As little is known about the microdosing effectiveness of how long, how often, and in which intervals. So maybe there's a strategy you could think of that would help to prolong the microdosing level.
Could be. Although the whole issue of microdosing is a delicate one. So there are some studies who even say if you are really doing microdosing, so below the threshold, there are objectively no effects at all. And everything else is not microdosing but mini dosing, because then you already have an effect. And I would propose that even 10 microgram of LSD do have an effect. So I wouldn't call that microdosing. If you are lower than 5 microgram, might be the area or the cutoff. But that's always mixed up a little bit. For some people, even 20 microgram is microdosing. For some might even think 50 microgram is microdosing, which is obviously not, because then you already have measurable effects. But of course, it's always subjective in a way, especially in these low doses, and you can't really differentiate from placebo effects, which probably play a greater role in this whole microdosing issue. But it's an interesting chapter on its own, I think. And I'm not so sure if you would reach the intended effects of microdosing if you have a steady release, because many people, they take a microdose in the morning and they do it every day, and then they have, of course, something like going up and down in the concentrations and it's more likely to have some subjective effects in such a condition rather than if you release it constantly. In fact, I would even expect, if you constantly release it, that you won't have any effects, because we know the phenomenon of tachyphylaxis for LSD, which means if you repeatedly take even higher doses, the effects will go down, and after some repeated doses, you won't have any effects anymore, any really dramatic effects at least. I wouldn't say any effects, that's not true. Of course, it does have any effects, but not the psychedelic effects at least anymore.
I was just curious about the drug interaction. Have you taken it together with some other psychedelics or other drugs to see the effect, and what was the effect, if so? And the therapeutic application of 1P-LSD would be the same as for LSD, correct? Because they act the same.
Yes, I would propose that. We did not. From a scientific point of view, it's very difficult if you mix things, you know, because you can have pharmacokinetic interaction, you can have pharmacodynamic interaction, and then you go into, you know, very undefined areas somehow. So for me, it's always important to be straight and look at one substance at a time. But of course, that can be interesting. I'm not really a friend of mixing different drugs. That's my personal taste. But I know that other people see that differently, and there might be some combinations which have some or even more potential as the single drugs themselves. So that's an interesting field, but it's even more difficult to do research in this field because you can have differences in metabolism of the single substances in different people, and then you would need to perform studies really with many people to really look deeper into that. And then you will have a big variability in effects also, I would assume. As we already know, and that's one of the problems for me as a toxicologist in mixing drugs. I don't know in detail my, you know, enzymatic genome and everything that I should know in order to get an idea of what really will happen if I mix, you know, A, B, and C, for example, in different doses. So that gets a bit of an adventure somehow. And I mean, adventures can be exciting, but can also be dangerous.
Thank you, thank you.
Okay, with that, we'll be concluding tonight's lecture. Thank you again so much, Professor Auwärter, for coming here.
Thank you.